So a lot of questions in the energy topic combine both maths and physics, and this one is a real test of both of those. So let's take a look at it. It says kangaroos are large animals that travel by jumping. And it says the photo shows a kangaroo below. We've all seen one before. Each leg of a kangaroo has a tendon connected to a muscle. Each tendon can be modelled as a spring. And it says when a jumping kangaroo lands on the ground, the tendons stretch. And now it breaks down that the maximum gravitational potential energy during one jump is 770 joules. And it says when the kangaroo lands, 14% of that maximum gravitational potential energy is transferred to elastic potential energy in one tendon. And it says the tendon has an unstretched length of 35 centimeters, and then when it lands, it has a stretched length of 42 centimeters. A lot of information there, all to calculate the spring constant of the tendon. Now they've given us the unit in the answer there, newtons per meter, but it's still 5 marks, plenty of work for us to do. Okay, so we want to find the spring constant. What equation are we going to use? I see energy there and I see about length there, so we're going to use EE for elastic potential energy is half KE squared. Remember, that is in your formula sheet, so you can refer to that. Now, to find these individual things, what is the elastic potential energy? So looking at the first part of the question, it talks about the 770 joules of gravitational potential, and it says 14% of that becomes elastic potential. So we're going to use that and say the elastic potential energy is 14% of the 770, the gravitational potential. So 14% is timesing by 0.14. So we times that and we get a value of 107.8 joules. So that's our elastic potential energy there. I'm going to give that a tick in our equation. So then the next thing we want to find is extension. Now in the second half of the question, it tells us it has an unstretched length of 35 centimeters and a stretched length of 42 centimeters. So for the extension, we would do the stretched length of 42 minus the unstretched original length of 35. So that's 42 minus 35 to give us a value of 7 centimeters. But that is not the standard unit. The standard unit is meters. So we're going to turn it into meters by dividing by 100, and that gives us 0.07 meters. One thing I've underlined here that's super important is that they've said this is for one tendon. Okay, so I've underlined that there. But remember, there are 2 legs, so there's 2 tendons. So we're going to need to multiply this value by 2. So the extension that we're going to use is 0.07 multiplied by 2, so that's 0.14 meters. That's the extension we're going to be using. Okay, so now we know the extension. I'll give that a tick. We know the elastic potential energy. There's only one unknown, the one we want to find, the spring constant. So let's substitute into the equation. 107.8 joules for elastic potential energy equals a half times the spring constant, which will leave us K because we don't know it, multiplied by our extension squared, 0.14 squared. Now we want to isolate K and make K the subject like we do in maths, so we move all the other numbers to the other side. So there's a times by half on this side, so to get rid of that, we multiply both sides by 2 and then divide by the 0.14 squared. So K equals 107.8 multiplied by 2 divided by our extension squared. And if you put that in your calculator, you should get a value that rounds to 44,000 newtons per meter. And that is what I will put as our answer there. So a tough question, 5 marks, plenty to consider. But if you take it step by step, show you're working out, you'll get those 5 marks.